So next we'll discuss about how to create arrays of particular type. So here is a list. One can use one. These are very important if you are making some codes in Python. Suppose you want to create a list from create an array from Python list, which has been already discussed. Then you can create an array of zeros also. np.zeros, I will demonstrate everything. np.ones, that will create an array of ones. np.diags means it will create diagonal array of elements. np.arrange, it will create an array where elements are evenly spaced. np.linspace, it will also create elements which are evenly spaced. Some fundamental difference is there between arrange and linspace. Mesh grid is also some similar kind of things that will create arrays in two-dimensional space. And random RND means it will create an array of random numbers between 0 to 1. So let us take one by one. I want to create an array from a Python list. So this is a Python list of 1, 2, 3, 4. I want to convert it into array. This you can do just by writing np.array within bracket list like this. I want to make a demonstration like this. So the simple way of writing an array list is this: np.array, put the first bracket. If there is a list or you want to create it, put the list like this. Then you put the elements. This your list array has been created. Give it a name and type it. Your array has been created. You want to check its dimensions, put n dim. It will give you the dimensions. One to check its shape. Shape is, there are 4. This is a single row array matrix. Sorry, not matrix, it's a single array. Size is 4. 4 elements are involved, 1, 2, 3, 4. Now let us take another example. I create a two-dimensional array. Suppose np.array. So this is the array that has been created. Just find out what is its dimension. It's a two-dimensional. And what is its shape? It is a 2 by 2. So this is how you can create an array. You can check its dimension, you can check its shape. Now suppose I want to create arrays of zeros. np.zeros. Suppose I write 5. So it is create an array of 5 zeros. If you want to make a two-dimensional arrays like this, you will get zeros like this. So np.zeros, it will create a array of zeros. Just mention the size of the array, that will produce the array of zeros. Similarly, you can create your array of ones also. np.ones, mention the dimensions, and it will create. That's all. Suppose you want to, you have created an array of ones and you want to fill it the values 5.4. The idea is something like this. Suppose np.14 means yet you have created array of 4 ones, but I now want to fill this array with 5.4. So what I will do, I will multiply 5.4 with this array, and you will get it like this. But there is another way you can do it. If you write np.full, how many number of elements do you want? Mention 4. With what element you want to fill it up? 5.4. You will get the same answer. So these are different way you can manipulate your arrays. You can manipulate, you can create an empty array also. np.empty, 5 elements you can create. Here it is coming, but sometimes you may find some unusual kind of numbers. If you create an empty elements, what are these numbers? These are some of the numbers. These are called garbage values, because it is picking up the numbers from the memory locations. It is treated as empty kind of things. Here also you can do the same operation. You can full with number 3 for the 5 elements like this. Okay. Now the most important functions it is there in NumPy is arrange functions. That is, if you want to create a evenly spaced values between two numbers, and if the step size you can select 1, 2 or whatever it is. The syntax is np.arrange start value, stop value, and incremental value. This is how you have to write it. So np.arrange 1 to 10 means it will create numbers from 1 to 9 with a step size of 1. Let us check it out. That's all. And in np.linspace, it will also create evenly spaced values between start and stop. But here you give step size. That is, what will be the step size between two consecutive numbers. But if you are not so much concerned about the step size, you are more interested in number of elements that you want in between two values, start and stop, then it is advisable that you go for linspace. Here syntax is start, stop, and number of elements. Say for example, if in between 1 to 10 you want to create 10 numbers, or maybe suppose 100 numbers. Then this is how it will immediately create all the elements like this. You can create 50 numbers also. So sometimes we are interested in number of elements between two specific values. Then it is always advisable to use linspace. But when you are concerned about, suppose step size, instead of 1, suppose you want say 0.1 should be step size for two consecutive, then go for arrange. Then that will create or evenly spaced values between two numbers. So that's all about arrange and linspace. Similarly, log space is there. It will create the values in the log scale. That is, if you have two numbers called 10 and 100, then 10 power is 0, and 100 is 10 square. So you have to write np.log space 0. So write it like 0 to 5. It will create it in the log scale like this. And mesh grid arrays means what? Suppose you have an array of array defined as x. For simplicity, just I'll consider x-axis. Suppose that is from -1 to 1. You have created an array, and suppose this is y-axis. Number is between -2 to 2. And you want to create a mesh grid that is in the xy plane. All the elements they are enclosed by these boundaries. Then the simple way you can do it is this one: np.meshGrid x and y. That will create the mesh grid for you, and you will get all the x values and y values within this domain. And that will be best understood if one can plot a graph in the three-dimensional plot. Probably I can show it in the graphic and data visualization sections. But at this moment, this can be done this way. So this is your X values, this is your Y values. So for creating a uniformly distributed mesh grid, this is the way one can go for this one. Suppose I want to calculate X plus Y whole square for all X and Y values within this mesh grid. So what we will do, I'll replace X by all these X values that has been created over this mesh grid, and Y means all the Y values that I have created in the mesh grid. So I calculate and take the squares and I get the values Z. So every point of this domain, this function will be evaluated and it will give you the answer like this. It is empty, I have already discussed. Right. So next one is that this is important. Suppose you are making a code and you want to create two arrays. Suppose the first and these two arrays should be identical in nature. Suppose the first array is the given one and the second array is an empty one, which you defined as either zeros and ones, but the dimensions of these zeros or ones array should be identical to the given array. And so this can be created like this one. Suppose you have an array called X given like this, and you want to create an array Y which should be array of zeros, but dimension should be identical to X. So what you will write, np.zeros like X. So you will create an array of zeros, but its dimension should be similar to X. Or you can create arrays of ones, but its dimension should be X. So you write ones like X. So this is how you can create a copy of array filled with zeros and ones like this way with a given array. So here it is. I write it separately, then it will be clearer. So here you see this was the given array of X 1, 2, 3, 3 by 3. I have created an array Y filled with zeros. Dimension is the same. I have created an array of Z, array of ones. Dimension is similar to X. So if you want to create an identical arrays either of zeros and ones, you can write it like zeros like which array you want to follow, just put it within this bracket. Or if you want to create an arrays of ones, you can write it like this way. So you can create a matrix array also, say array of identity. So np.identity4, that will create an array whose diagonal elements are all ones. If you want to create an array of identity matrix upper diagonal elements, so you write simply np.i3k1, it will give you upper diagonal elements. That is, all diagonal and lower diagonals are 0, only the first one is 1 and 1. This is why np.i3k1, that will give you the answer. And if you want to create a lower diagonal elements ones like this way, just one diagonal like this, you can do it like this. Now to construct a matrix with arbitrary one-dimensional array, you can write it like this. That is, diagonal elements are incremented in the step of 5 from 0 to 20. 20 will not be taken. So 0, 5, 10, 15. This is how you can create a diagonal elements of a matrix. That is, now comes the most important part of NumPy array. That is indexing and slicing. And if one is not very much clear about indexing and slicing, one will face a lot of troubles in coding the Python programs, or even plotting the graphs also. But this is not a very difficult kind of things. Just one has to practice little bit, then it will be get habituated. Suppose I have an array of A, and if I write M, which is an index of this array, that is mth elements, we always count array first index position is 0. So if it is a length n, so index will run from 0, 1, 2, 3 up to n minus 1. So if I write m, so select an element at index m, where m is an integer counts from 0. That is always understood. If I write a minus m, so it selects an mth element from the end of the list. That will be, everything will be explained this way. Let me go out very quickly. A m to n means element starts from m, index position m, and go up to n minus 1. A colon within square bracket or a colon minus 1, that means select all the elements of the given axis. A colon n means you select all elements from 0 up to n minus 1. A m colon blank means select elements from the mth index and up to the last element. If you write m n p means start from m and go up to n with an increment of p, and this represents select element in the reverse order. Here is a very beautiful pictures that will tell you the whole things. Oh no, okay, it's okay. This is a figure that I have taken from one book which I have already mentioned, Numerical Computations by Robert Johansson. So this book is available in the net. If you are interested, please go through the particular page and get yourself accustomed and familiar with the indexings. So if you write, suppose this is a 3 by 3 kind of arrays, data are indexed like this. 0, 0. This is the position 0, 0. This is 0, 1, 0, 2, 0, 3. That means this is the first row is labeled as 0. First column 0, second column 1, third column 2, and fourth column 3. Second row is indexed as 1. So it is 1, 0, 1, 1, 1, 2, 1, 3. Third row is indexed as 2. So it is 2, 0, 2, 1, 2, 2, 2, 3, so on. So this is the way what we label the elements in the array. Now if I write suppose data 0, this means I select all the elements in the first row, because 0 stands for first row. If I write suppose data 1 comma colon, that means go to the second row, the first row, second row. So this is the second row, colon blank before and after means you select all the elements in the columns. So this is the first column, this is the last column. That means data 1 means this is the row, and column all means you select all the elements. So this is marked as blue. Now if you go like this, data colon comma 2, that means data colon means first it is stands for row. So select all the rows. 2 stands for, it is the third column. So 0, 1, 2. So this is the column and all rows. So all the rows, this is marked as blue. Similarly, data 0 to 02, that stands for you select all the rows from 0 to 1 and column from 0 to 1. So 0 row, first row, and 0 column, first column. So this is the selections. Similarly, other selections you can try it out. This is the protocol or the way one has to represent the numbers, or one has to select the elements from an array. There is another example, it is there, one can try it out. If I write A0, 3, colon 5, that means first row, third column, 2, 3, 4, 5. So it will be, this is the first row, 0, 1, 2, 3. So this is the third column and fourth column. 5 is excluded. So this is the selection, 3 and 4. Answer is 3 and 4. One can check it out like this. So this is how others can be also verified, and one can get accustomed with the indexing. So I have created a simple array of numbers from 0 to 9. If I write A0, what should be the answer? It should be 0. A minus 1, it will give you the answer 9. If you write 4, A4 means fifth elements, 0, 1, 2, 3, 4. It is giving you the answer 4. So this is how you keep on practicing the things like this way. So A1 to minus 1 means it selects a range of elements from second to second last. So it will be 1 to 8. A colon means all elements. And similarly, A 1 to 1 means in a step of 2. 1, 3, 5, 7. So this is the things going on. Up to 5 means 0, 1, 2, 3, 4. 5 excluded. Minus 5 in the reverse order. This is in the step of 2 in the reverse directions. So next comes multi-dimensional arrays. So this is a multi-dimensional array I have created with these functions, and this is the elements. So A colon 1 means what? You select all the rows. All the rows you select, but first column means 0, 1. So it is answer will be 1 up to 51. Yes, you have got it. Now the second one means A1, 1 means second row, 0, 1, and all columns means 10 to 15. You have got it. So this is how you practice, and you will be very familiar with this kind of things. You can check it out later. Now let me introduce you how to manipulate size and shape of arrays in NumPy. That is, if an array is given, you can reshape it. Suppose 3 cross 3 matrix is given, you can shape it to 1 cross 9 or something like this. You can flatten an array, you can transpose an array, you can H tag, V tags. These are some of the functionalities are there. That is how you can change the shape of the arrays. Let us take one by one. Hello, Kullan. Hello.
Hello.
How much time is there?
If time till 1:30.
1:30. All right. I hope I can finish it. So I have created an array 1, 2, 3, 4. So it looks like this. So what is the shape of this array? Let us find it out. It's 2 by 2. I want to shape it into the form 1 by 4. So what I will write, data dot reshape 1 by 4. So it is now transformed from 2 by 2 array to 1 by 4 array. So if it is required that you have to change the shape of the array, you have to do it like this. If you want to write it like data reshape 4, then just write the shape and it will give you an answer. If you want to flatten the array, that is, you have an n-dimensional array and you want to collapse into one axis, then just write it this way. You have 2 by 2, you have flattened. So if you write flattened, then you need not have to write its dimensions. It is understood that it is collapsing into single axis. And if you check its shape now, then it will give you that yes, it has collapsed to single axis. If you check its dimensions, it is given dimension 2, shape 2 by 2. Transpose means changing the axis. That is, rows goes into column, columns goes into rows. So here is a demonstration. So I have created a data of 9 elements, one dimensional. Then I reshape into 3 by 3 arrays. Then I want to transpose this data. Then you can see it is column goes into rows and rows comes into columns. So in one syntax, you can accomplish the whole things. Now I want to represent how you can stack a list horizontally, that is along the axis 1. Suppose you have a one-dimensional array represented like this. You give it a shape to 5 by 1. Now you want to stack it horizontally along the axis 1, write h stack 1. So you have got it like this. It has been stacked. More data you put, it will be stacked like this. Yes, it is done. And v stacks means just opposite. You have to stack along axis 0. Vertically, you have to do it. Same elements. Vertically, you are stacking one after another. Concatenations, it's combinations of h stack and v stack. That is, a choice is there. You can put your choice along which axis you want to concatenate. It is similar. More way, it is similar to v stack and h stack. So if you want to concatenate A and B along axis 0, so it will give the answer like this, and along 1, then answer something like this. So you can try it out and you can find the difference between these two. Now you can append an array, that is, you can add some elements. You have already an array of A, and you want to add an element 5 to it, so you write just this way. So 5 has been introduced into the array. Now this is the last one, vectorized expressions. That is the very soul heart of whatever you say about the NumPy array, because that makes the calculations very efficient one in Pythons. Now what is vectorized expressions? Earlier in Python, in conventional way, core Python, you have calculated the operations element wise. Now here you have created array. When you have created array through vectorized expressions, you are carrying out your operations not element wise but array wise. So it will take into account all the elements of the array. So if you have 10 elements in core Python, it has calculated 10 elements one after another. But in vectorized expressions, it will consider 10 elements together in one step. It will calculate the 10 elements taken together through an array. That is why it reduces the calculations time also. This is a concept through which array operations are taking place. I didn't like to discuss about this one, broadcasting, but time is also coming short. If possible, I leave it to you, or otherwise tomorrow I will discuss this one. This is a kind of operation that will explain how array operations are taking place in NumPy array. This is a suppose 3 by 3 array, and you have want to add it with a 1 by 2 array. So it will manifest it into 3 by 3 array, so that two sizes becomes compatible, and then it carries out this sum operations or addition operations. So before array operations, then the two arrays make themselves compatible with each other before operation takes place. This is something called broadcasting. So arithmetic operations are similar to the arithmetic operation we have discussed in the last class. Addition, subtraction, all these things are similar. And the difference is that if you have created an array of x and array of y, you can add x and y simply by writing x plus y, and it will do the same job like. So 1 plus 5, 6, 2 plus 6, 8, 3 plus 7, 10, 4 plus 8, 8. So you don't have to write separate. You did not have to write a for loop like these things. That is, you have to consider elements, each element separately, and add it to the elements of the other array. But if you simply write the two arrays and sum them, it will give the answer. Similar answer you will get it for subtractions of y minus x, or if it is for multiplications of the two arrays, simply write the array with multiplication signs, or divisions that can be done also. It can do the scalar array operations. Suppose x is an array and 2 is a scalar. So if you want to multiply the array with each element of the array by a number 2, just write x multiplied by 2, it will do the job for you. And if you want to suppose take an operations like 2 to the power x, that is x is the number of elements of the array, just write this way, it will carry out this array operations. Or similarly you can do it by y by 2. So all these kind of operations, the scalar array operations, can be done by just simply writing the arithmetic uh, way of writing the syntax, suppose what is called. Next comes, okay, so this is important. If an arithmetic operation is performed on arrays of incompatible size or shape, a value error exception is raised. Suppose you have an array of x whose shape is something 1 by 4. Now if you make it suppose shape 2 by 2, and now you divide, you have created an array y like this, and if you divide by this one, then it will raise an error expressions, because their shapes are not compatible with each other, because one is of shape 2 by 2, another is shape of 4. So that is not possible. So shape has to match each other. Then there is an element wise functions, that is in addition to arithmetic expressions using operators, NumPy provides vectorized functions for element wise evaluations of many elementary mathematical functions and operations. So, for example, cos function, sine function, trigonometric functions are there. There are inverse trigonometric functions, hyperbolic functions. These are there. Square root functions are there. Exponential functions they are there. They can operate over the array like this. Suppose you have created an array of x, which is in elements from -1 to 1. In between 11 elements are there. So it looks like this. Now we want to calculate sign of each element. So what you will write, np.sign, within bracket you write the array. You could have written or before that, as I have told you, sign takes the argument in the form of radians. So you have to convert it into radians by writing np.radians x, and it will give you the answer in one shot. And you can also control the number of places of the decimals also. That is, if you write np.round with the number of decimal places, then it will give you the most things like this. So all elements are having restricted up to 4 places of decimals. So extra formatting is not required. Just mention the decimal places, it will give you the answer. Now you can add 2 arrays or subtract 2 arrays, multiply or power other kinds of things. There is many mathematical operations functions operate on 2 input arrays and return 1 array. This already I have explained. Suppose you have one array of sine x square, another array of sine cos x square, and as you know, if you add sine x square, sine square x and cos square x, what you are expecting? Simply an array which will give you the answer 1. Or you can write it this way also, that is just write plus. So these 2 results are identical. This tells you
Subedha,
that if you write, yes,
time is almost running short, so the rest of the things can be done tomorrow, I guess.
all right. So I'm already finished, as I have 1 or 2 topics, just it will take. So it is this way, by adding this np.add functions, you can add 2 arrays, or otherwise you can add the arrays together like this plus signs. You know, these are identicals. So I stop it here. So I don't have much topics to left behind, only a few topics. Otherwise, okay. So, okay, you can disconnect it now.